Hello all, welcome to Docker Basics to Brilliance course. My name is Kastro Kiran. In the last video, we have understood the Docker Basics commands part 2. As a part of this particular video, we are going to talk about three important concepts that are available in the Docker. The first one that we are going to understand is known as the creation of custom Docker image without using the Docker file. So technically, whenever you want to create a Docker image, we need to have the Docker file. But currently, we have not discussed anything that is related to the Docker file. So I'm going to create the Docker image without using the Docker file. Once after creating the Docker image, by using the Docker image, I am going to create the container. That's called as creation of container from the custom Docker image. Once after we create the container from the custom Docker image, then we are going to copy the content from container to the image. These are the three things that we are going to discuss as a part of this video. Altogether, we can call this concept as OS level virtualization. So what is meant by OS level virtualization and how these three concepts are going to help us in order to work with the OS level virtualization? We'll be seeing it now. Firstly, let us understand what is meant by OS level virtualization. In the previous videos, we have understood what is meant by virtualization, what is meant by containerization, what are the differences between the virtualization and containerization. So in this video, I'm not going into the details of the virtualization concept. If you haven't understood what is meant by virtualization, I would recommend you to watch the video where I have discussed about what is meant by the virtualization and the containerization. But in a nutshell, let us see what is meant by virtualization. Virtualization is the process of, it is the process of using the resources, it is the process of using the resources in an effective way, in an effective way. What does it mean? Now, let's say you have the host operating system. So firstly, you will be having the hardware components. On top of hardware components, you will be having the host operating system. On top of hardware components, you will be having the host operating system. On top of host operating system, we are going to install the hypervisor software. We are going to install the hypervisor software. On top of hypervisor software, we are going to create virtual machines. It can be one machine, it can be multiple machines. Inside the virtual machines, we are going to install the applications, and these applications can be one or many. So this is in simple about the virtualization. But what does it mean by OS level virtualization? OS level virtualization means, OS level virtualization means, let's take it as an example. For example, if I have an operating system, if I have an operating system, inside the operating system, inside the operating system, I have some folders, files, softwares, packages. Let's say you have multiple things that are available here. Some code, the source code of the application. Like this, you are going to have multiple things inside the operating system. Inside the operating system, I have some folders, files, softwares, packages, source code of the application, etc. Now, in this case, if I want to, if I want to take the backup, if I want to take the backup of complete operating system, complete operating system, it is known as, then it is known as OS level virtualization. Then it is known as OS level virtualization. So what does it mean by OS level virtualization? If you have an operating system, you know that inside the operating system, we can install the softwares, we can install the packages, we can deploy the code, we can create the files, we can create the directories, anything that we can do. Now, what I want is, I want to take the backup of the complete operating system. That means whatever that is there inside the operating system, I want to take the backup of everything that is available inside the operating system. When you are taking the complete backup of an operating system, that process is known as OS level virtualization. That process is known as OS level virtualization. Now, we will do this practically by working with the creation of a custom Docker images and then we are going to work that. However, in order to create the custom Docker images, we need to have the base image. Whatever that we want to do in the Docker, firstly, we have to install the base image, we have to download the base image. On top of base image only, we are going to work. Let us see how to pull the base image, and then we will see how to work with the different aspects of the OS level virtualization. So currently, if you see, I have already started my EC2 instance. It is in the running state, and I have already connected to my EC2 instance as well. So let us verify whether the Docker is in the running state or not. So in order to verify whether the Docker is in the running state or not, we have this thing sudo service, okay, sudo service Docker status. If you click enter, you can see the Docker is actually in the running state. So now the Docker is currently working. Let's see what are the images that are available. You can see I have the images such as Amazon Linux image, MySQL image, Hello World image. Now you know how to remove a specific image and how to remove the containers we are going to discuss in this session. But currently, let me show you how to remove the images and how to remove the containers. Then we are going to talk about the OS level virtualization concept. So firstly, let me remove the Amazon Linux image. So how will you remove the image? So Docker space RMI. Okay, Docker space RMI, and then give the image name. What is the image name? Amazon Linux is the image name. So let me give the image name as Amazon Linux. I want to remove this particular image called Amazon Linux. So let's click enter. Since with this particular image, there is a container that got attached. So we need to first delete the container and then we can delete the image. Now let's say I want to delete the image directly. So without deleting the container, I want to delete the image. We can do that also. So in order to delete the image without removing the container, directly we can use Docker RMI -f and then image name. This command we have seen in the last session. You can see the image got deleted. If you do Docker images, the Amazon Linux image has got deleted. Now, similarly, can I remove other two images? Yes, Docker space RMI -f. Now I want to remove both MySQL image and Hello World image. So for that, I am just giving the image names. MySQL is one image name and the other image name is Hello World. Instead of giving the image names, you can also give the image ID whenever you want to remove the images. So let me click enter. Now you can see the images has got deleted. Both MySQL image and also the Hello World image has got deleted. You can see them. Now if you execute Docker images, you don't see any images that are available. Let me clear the screen and execute the command once again. Docker images, you don't see currently there are no images. Can we see the containers? Yes. Docker PS is used to show the, or it is used to see the running containers. Currently, do we have any running containers? No. If you want to see all the list of containers, then we have a command Docker PS -a. You can see there are a couple of containers that are available. So let us delete these containers also. But before deleting these containers, let me zoom in, let me zoom out a little bit so that I'll be able to see the container names also. Docker PS -a. You can see the container called Kastro is there, container called container 001 is there, and there are a couple of other containers that got created also. Now, let's say you want to delete a container. So to delete a stopped container, okay, the container must be stopped. So to delete a stopped container, the command is Docker space rm space container name. Instead of container name, you can also give the container ID. So by using this particular command, we can remove the container. Let's see whether we can remove the container or not. Okay, let's see whether we can remove the container or not. So for that, let me say I am going to remove a container which is called as container 001. Okay, I want to remove this container called container 001. Docker space rm space container name. What is the container name? Container 001. So let me click enter, and now the container has got deleted. Can we verify whether the container got deleted or not? Yes, Docker PS -a. Now, if you see earlier container 001 is available, now it is not available. So that's how you can remove the container. Now let's say I want to remove all the containers which are in the stopped state. Exited means they are in the stopped state. So I want to remove the containers which are in the stopped state. So can I remove all the containers? So to remove, okay, to remove all the containers in the stopped state. Okay, to remove all the containers in the stopped state, to remove or delete. So let me call it as delete only instead of remove. So in order to delete all the containers that are there in the stopped state, we have this command which is known as docker container prune. Okay, this is the command that is used in order to delete all the containers that are in the stopped state. Docker prune docker container prune. Okay, right. So now let's say this is one command that you can use in order to delete all the containers in the stopped state. Now, let's say I want to delete, okay, to delete or to remove anything you can say, to delete all the stopped containers, okay, to delete all the stopped containers and images or unused images, you can say, unused images and unused networks. Okay, networks concept we will be talking over a period of time, but let us not bother much about this. But the command remains same for all the three. If you want to delete all the stopped containers, unused images, and unused networks, we have the command which is known as docker system prune -a. Okay, docker system prune -a. What does this will do? It will delete all the stopped containers, unused images, and unused networks. So that's the importance of this particular command. So firstly, let me delete all the containers in the stopped state. So what are the containers that are there in the stopped state? You know. So these are the three containers that are there in the stopped state. So how will you delete all the containers in the stopped state? Docker container prune. Okay, this is the command. So let me click enter. You can see this will remove all stopped containers. Do you want, are you sure you want to continue? Yes, just type Y and then click enter so that it will delete all the containers that are there in the stopped state. Now, earlier we had three containers. Now let me execute docker ps-a so that you will not see any containers. So that's how you can delete the containers which are there in the stopped state. But let's say if you have the container which is in the running state, okay, to delete a container, let me write this one also. To delete a running container, okay, to delete a running container, firstly, you cannot delete directly. Firstly, you have to stop the container. Okay, you have to stop the container. So how will you stop the container? In order to stop the container, we have the command docker stop container name. Okay, docker stop container name. This is the command that is used to stop the container. Once you stop the container, then you can remove the container. Docker rm space container name. Remember, in the place of container name, you can also give the container IDs as well. Both you can give. Okay, that's how you can delete a running container. In order to delete a running container, first you have to stop it, then only you can remove it. Right. Now, let's say I want to delete everything that is available, the unused images, unused networks, stopped containers, everything. Currently, we don't have a stop. We don't have the containers because I have deleted all the containers which are in the stopped state by using this particular command. Now, let's say, let me clear the screen first. Now, let's say Docker images. Now, currently, I don't have any Docker images also. Let's say I will pull a Docker image just to show you the command of docker system prune -a. I'm going to pull the image. So how will you pull a image? We know that in order to pull a Docker image, we have the command docker pull. Okay, let's say I want to pull a command, pull as image, which is known as docker pull hello world. This is the image that I want to pull. So that means it is going to get downloaded. Once it gets downloaded, then I want to remove everything. Okay, all the stopped containers, unused images, unused networks, everything I have to remove. So how will you remove all the stopped containers, all the unused images and unused networks? The command is docker system prune. Okay, docker system prune -a. So click enter. You can see this will remove all stopped containers, all networks not used by at least one container, all images without at least one container associated to them, and all build cache. So it will remove everything of this. Yes, if you want to continue, then just press Y and then click enter so that it is going to delete everything. Now, earlier we have pulled the Docker image. Okay, we have pulled the Docker image. Now, if you do Docker images, you don't see the images. That's how you can remove everything that is the stopped containers, unused images, and unused networks. Right. So now let us go back to the OS level virtualization concept. So in order to understand this concept, currently, let's see whether we have any kind of images or not. You can see there are no images. Let us also see whether do we have any running containers or not. Docker PS, there are no running containers. Let us also see whether the containers are in the stopped state or not. Click enter. So there is nothing available. So there are no images, there are no running containers, and there are also no containers which are in the stopped state as well. Right. So now what I will do is I am going to pull an image. Currently, I have the Linux-based EC2 instance. Now what I am going to do is on top of Linux-based EC2 instance, I am going to pull an Ubuntu image. I'm going to download an Ubuntu image. So how to download an Ubuntu image? So in order to download an Ubuntu image, we have the command docker pull space image name. What is the image that I want to download? Ubuntu. So just give Ubuntu and then click enter so that the Ubuntu image will get downloaded into my EC2 instance. What instance I have? Linux-based EC2 instance. On top of Linux-based EC2 instance, what I have downloaded? An Ubuntu image I have downloaded. Let's verify. Docker images. You can see the Ubuntu image is available, which is having a size of 76.2 MB. That's how we can pull the Ubuntu image. Now, let's say I want to create a container. Okay, I want to create a container. So in order to create a container, what is the command? Docker run. I am first creating the container and then I will run it both at the same time. So in order to create and run the container at the same time, we have to use interactive mode, IT space hyphen name. Let's give the container name. So container 001. This container is not available. Okay, currently I'm going to create a container. Docker run -it -name. What is this one? This is the container name. You can give any name here. You don't have to give directly container 001. You can give your own names or whatever names that you want. Okay, so Docker run -it -name container 1. For which image I want to create this container? For the image called Ubuntu. Okay, for the image called Ubuntu. Remember, this should be the same name, whatever you have downloaded. Make sure of it. Okay, so click enter. Now, what will happen? The container has got started. Okay, the container has got started. Now, if you see root at the rate, some option you are seeing, something you are seeing, right? That means you are there inside the container. Every time you don't see /bin/ash, based upon the image that you are going to pull, this will get varied. Okay, remember this, this will get varied. Now, currently, since I am working with the Ubuntu image, okay, since I am working with the Ubuntu image, this is the one that is showing to me. If it is a Linux-based image, then it was showing me /bin/bash that we have seen in the last session. Right. Currently, I am there inside the container. Okay, I am there inside the container. Now, let us update the Ubuntu software. Okay, let us update the Ubuntu. So how will you update? Apt, okay, apt update -y. So yum is used for Amazon Linux. Apt, why I am using? Because I am there inside the container. Okay, currently I am there inside the container. So I want to update the packages that are available inside the container. So in order to update the packages, apt update -y. So click enter so that the packages will get updated. Once the packages gets updated, what I will do is I will install a couple of softwares and a couple of files I am going to create. Let us see that, how to work with that. So let me clear the screen. So currently the package has got updated. Now let's install the Git software. But before installing the Git, let's verify whether Git is available or not. So you can see command not found. That means Git is not available. Okay. Let us also see whether Maven also I'm going to install. Maven is also available or not. Command not found. That means Maven software and Git softwares are not available. So how will you install the Git software inside the Ubuntu instance? In order to install the Git software inside the Ubuntu instance, the command is apt install git. Okay, apt install git -y. So click enter so that the git software will get downloaded into the Ubuntu machine or into the Ubuntu image. Okay, into the Ubuntu container, you can say. So first I have pulled the Ubuntu image, and then by using that image, I have created the container. Then I went into the Ubuntu container. Inside the Ubuntu container, what I have done, I have installed first Git. Let's verify whether Git has got installed or not. Git -- version. You can see the Git software has got successfully installed. Let me clear the screen. Now let's install the Maven software also. So apt install Maven, Maven. This is the command that is used in order to install the Maven software. Why I am using apt here? Because it is an Ubuntu container, not the Linux image. If it is Linux container, then you should use yum. If it is, since it is the Ubuntu container, I am using apt as the package manager. So click enter so that the Maven software will also get downloaded. Once the Maven software also gets downloaded, let's verify whether Maven has got really downloaded or not. So in order to verify whether Maven has got downloaded or not, we have the command which is known as mvn space -- version. Okay, mvn space -- version. So let it get downloaded, then we will see that. So you can see the downloading process is going on. So before that, I mean, let it get installed. Before that, by the time it gets installed, let me write the notes also. So OS level virtualization. Okay, OS level virtualization. So in order to work with this concept, first what I have done, I have pulled the Docker image. Okay, let me write that. So Docker, okay, Docker pull Ubuntu. Where I'm pulling the Ubuntu image, I'm pulling the Ubuntu image on top of the EC2 instance. And then let me check the Docker images. So then execute the Docker images. Now to create a container. Okay. So Docker pull, let me write in this way, to pull the Docker image. Okay, to pull the Docker, Ubuntu image, not Docker, to pull the Ubuntu image. Okay, right. Let me just give me a second to pull the Ubuntu image. And then the next command is to see the list of image. Okay, to see the list of images. To see the list of images. When you execute Docker images, what image you should see? Ubuntu image you should see. Once after you do this, then let us create the container. Okay, to create and run the container. Okay, to create and run the container, we have the command docker run -it --name. Okay, --name, and then give the container name, whatever name that you want, you give the container name, and then give the image name. Okay, and then give the image name. So once you do this, what will happen? It will create the container and it will run the container. Okay, to create and run the container, to create and run the container at the same time. This command we can use. Okay, right. So once after creating the container and running the container, you will go inside the container. Okay, you will go inside the container. So now you will be inside the container. What container? Ubuntu container. Now you will be inside the Ubuntu container. So what is the name of the Ubuntu container? Whatever name that you give here, that will be the name of Ubuntu container. Okay, that will be the name. Whatever you give here, that will be the name. Remember, it's not actually the name of the container is not Ubuntu. I'm just mentioning it as Ubuntu container based upon the image that we have pulled. Okay, so let me write it. That is container 001 in my case. That is, I am practicing, right? So in my case, my container name is container 001. Right. So now, once after you do this, let's update the packages. Okay, how will you update the packages? Apt, okay, apt update -y. Okay, apt update -y. So this command is used to update the packages. Okay, to update the packages. Once you update the packages, let me install a software. Okay, let me install a software. What software? Apt install git -y. So I'm going to install the Git software. And then I am going to verify git hyphen version. Okay, and after this I am going to install the maven software also, apt install maven hyphen y, and then verify whether maven is installed or not, mvn space hyphen version. So this particular command, let me write it here. Just give me a second. I'm just going to write it. So to verify the git installation, okay, to verify the git installation. And then if you want to verify the maven installation also, we are going to use this command, which is known as mvn hyphen version, to verify maven installation. Okay, so this is actually to this one. For this one, it is git hyphen version is to verify the git version. And then the next one is to install git. Okay, to install git. And the other one is to install maven. Okay, to install maven. Right. So now currently where I have installed the git and maven, currently we have installed the git and maven software inside the container. Okay, inside the container. What is the name of the container? That is container 001. How we have created the container based upon the image. For which image we have used Ubuntu image. I'll tell you that in some time. So currently the maven has got installed. Let me verify the maven has got installed or not. You can see the maven hyphen version. Maven Apache Maven 3.8.7 has got installed. Now let's say I want to create some files. Can I create some files? Yes. So touch space. Let's say I want to create a files with the name file. Okay. Let's say I want to create some two files with the name. So this is a simple Linux command. In order to create two files at the same time, I want to create a Python files .py I'm giving. So click enter, so that what will happen if you do ls, two .py files will get created. File1.py, you can see file1.py and file2.py. So this command is used to create two files at the same time with this particular extension called .py. Can you create a .java files? Yes. How will you create it? Touch space file. Okay, let me give, instead of file, I'll give it as Java. Let's say I want to create two .java files. So if you want to create 5, you can give 5. If you want to create 10, you can give 10. That's up to you. So currently I'm going to create two .java files. Click enter. If you do ls, you can see java1.java and java2.java. So currently what I have done, I have installed two softwares, Git and Maven, and I have created two Python files and two Java files. Okay, two Python files and two Java files. Now let's come out of the container. So how will you come out of the container? Control D. Okay, Control D is to come out of the container. Now let's verify whether containers are available or not. So how will you verify whether containers are available or not? Let me clear the screen first and let me zoom out. And then docker ps-a. You can see the container. What is the container name? Container 001. Okay, the container is container 001. So that's how you can work with the creation of containers. Right. So this and all we are being aware of. Now inside the container, what is happening? We have the image. Okay, inside the container. So for workflow, I will write. So inside the container. Okay, inside the container, we have the Ubuntu image. Okay, we have the Ubuntu image. Now, by using Ubuntu image or inside the Ubuntu image, okay, inside the Ubuntu image or by using Ubuntu image, anything we can say. Inside the image, let's say inside the image, what is there? Operating system is there. What is that operating system name? Ubuntu operating system. Okay, Ubuntu operating system is there. On or inside the Ubuntu operating system, okay, inside the Ubuntu operating system, we have installed Git and Maven software. Okay, we have installed Git and Maven software, and also we have created two Python files and two Java files. These things we have done. So inside the container, we have the image. No, sorry. Firstly, what we have done, we have pulled the image. Okay, firstly, we have pulled the image. And now Once after pulling the image, what I have done, I have created the container. Now inside the container, what we will be having, we will be having the image. Okay, what is that image name? Ubuntu is the image name. Okay, Ubuntu is the image name. Inside the Ubuntu image, I was telling you in the first session, sir, and Docker image is a package of operating system. Docker image is basically consisting of operating system. Image is an operating system. Container is an application. If you remember in the previous sessions, we have talked about that. Image is an operating system, or image acts like an operating system. Container acts like an application. So inside the Ubuntu image, operating system is there. Inside the operating system, that is Ubuntu operating system, I have installed the Git and Maven software, and also I have created 2 Python and 2 Java files. Okay, this is what we have done so far. Okay, so if you do ls also, you can see what are the things that we have created. So let me execute ls command here. So currently I'm out of the container. I mean, I'm not there inside the container, but we have seen that. You can see here. Okay, so when I was executing ls command, you can see Python files are there, 2 Python files are there, and 2 Java files are there. Along with that, we also have the Git and the Maven software. Now let's do it in this way. Okay, now let's say I want to copy the content from container to image. Okay, I want to copy the content from, let's copy the content from container to image. So what is the content that is there inside the container? Inside the container, okay, inside the container, we have, what are the things that we have? We have Git software, okay, we have Maven software, we have 2 Java files, okay, and 2 Python files. These are the things that are there inside the container. Now what I am going to do, I am going to copy all these things into another image, okay, into another image. So I'm going to create one custom image here. That is what I'm going to do. Okay, so inside the container, we have Git, Maven, and 2 Java files and 2 Python files. All of these files, okay, all of these files, and if you have any kind of packages also, they're all running where they are running in my operating system. What is my operating system? Ubuntu operating system. Now what we will do is, let's create our own image. Okay, now let's create the custom image. Okay, let's create the custom image. Okay, let's create the custom image. So how we are going to create the custom image? Using the container 001. Okay, using the container 001. We have created the container, right? By using that container, we are going to create the custom image. Now, am I creating the image by using the Docker file? No, I am not creating the image by using the Docker file. So how I am creating the image? First, I have created a container. Inside the container, I have installed a couple of things, and I have created a couple of files. And then by using all these things that are available inside the container, I am going to create a custom image. Okay, I'm going to create a custom image. Now, I am going to give the name. Okay, the name of the image. Okay, the name of the image I am going to create is Kastro. So I'm going to create an image with the name called Kastro. Okay, with the name called Kastro. Now, what will this new image contains? The new image. Okay, the new image. What is the image name? The new image name, that is Kastro image. Okay, Kastro image. Let me write that. Kastro image contains the content, whatever, let me write that, whatever that is available in container 001. Let's do this practical. Okay, whatever that is there inside the container 001, all those things will come into the image called Kastro image. Okay, now the thing is here, in order to copy the content, okay, to copy the content from the container to image, okay, from the container to image, we will use a command which is known as a commit command. Okay, we will use a commit command. Let's see how to do that. So firstly, let me verify what are the things that are available. So let me give Docker images You can see I have only one image, that is Ubuntu image. Now Docker ps -a will show me the list of containers that are there. You can see container 001 is there. All right. So now currently what we are going to do is we have one Docker image and one container. Okay, we have one Docker image and one container. Now what I will do is I am going to copy the content from container 1 to a new image called Kastro. So how will you do that? So to copy the content from container to image, we will use commit command. The command goes in this way. Okay, the command goes in this way. Docker commit. Okay, Docker commit, and then give the container name. Okay, container name, and then give the new image name. Give new image name, or give custom image name. You can say instead of new, custom image name. You can give any name here, but container name should be matching with the existing image, existing container name. Let's see that. So Docker, okay, Docker commit space. What is the container name? Container 001. It is available here. Okay, from this container, what I want to do, I want to create an image. What is the image name? I want to give the image name as Kastro. Okay, I want to give the image name as Kastro, or you can give small letters also. Let me give the small letters only. Okay, so here what I am doing, whatever the things that are there inside this particular container, I am going to copy all the things into an image which is known as Kastro image. Do we have the Kastro image? Can you see Docker images? Do we have the Kastro image? No, only Ubuntu image is there. So when you do commit, what will happen? Whatever things that are there inside this container will get copied into this particular image. If this image is not available, it will create that image. Okay, commit command will create the image also. Okay, commit command will create the image also. Right. So let me click enter. You can see the image is getting created. The custom image, it will take some time and it will get, the image will get created. So you can see the image has got created. Okay. Now let's say what I am doing here, I'm copying the content from container 001 to an image called Kastro. Now, can I see the Docker images? Yes. If I execute Docker images, what should I see? Along with Ubuntu image, I should also see this image called Kastro. Let's verify that. Click enter. You can see Ubuntu image was there earlier itself. Now you can see I have the Kastro image also. Okay, I have the Kastro image also. That's how you can create custom images by using the containers. By using the existing containers, you can create your own custom images. Okay, now currently how many images you can see? Two images. First one is Kastro image and the second one is Ubuntu image. This is the image that we have pulled. Have we pulled this particular image? No. How I have created this image? By using the container. Okay, by using the existing container, I have created the custom image, which is known as a Kastro. Now what we do is from Kastro image. Okay, this is the custom image, right? By using this custom image, can I create a container? Yes, it is possible. So let's do that. So to create a container, from the custom image. Okay, from the custom image. So if you want to create a container from the custom image, okay, from the custom image, what we have to do is we have to execute this command. So for that, we have the command docker run -it -name, same command. Okay, container name you should give, and then image name. Okay, image name. So this is how you can create a container from the custom image. Okay, right. So it will create the container and it will also run the container. Both it will do. Okay. So now what we are doing, what we are going to do is from the image called Kastro. Okay, from the image called Kastro, I am going to create a container. That container, I am going to give it as container 002. I'm going to name that container as 002. Now this container, that is container 002, should have all the content that is there inside the Kastro image. That's our intention. That's called as OS level virtualization. Whatever the container I am going to create now, by using the custom image, that particular container should contain everything that is available in the image. Let's verify that. So how will you do that? Docker run Okay, Docker run -it, that is interactive mode, hyphen name. What is the name of the container? I'm going to create a new container with the name called container 002. Okay, now by using which image I'm creating this container, by using an image known as Kastro. You should give exactly as it is here, or you can give the image ID also. Anything will work. Okay, now let me click enter, and now I am there inside which container? Inside this particular container called container 002. Now let's say if I execute ls. Okay, if I execute ls, what files I should be able to see? I should be able to see 2 Java files and 2 Python files. Let's verify that. Click enter. Now, can you see? I have 2 Python files and I also have 2 Java files. Along with that, I should also have Git and Maven software. How will you verify whether Git and Maven softwares are there or not? Git hyphen version. If you see the version number, that means Git is also available. Click enter. Can you see? Git is also available. Can I see the Maven also? Git Maven hyphen, that means MVN hyphen version. Click enter. You can see the Maven version is also available. Are we able to get that? Yes. So that is how you can work with the concept. Okay, that is how we have worked with the concept. This particular concept is known as OS level virtualization. Now, what I have done, whatever that is there in the image, by using that image, that is custom image, I have created a new container. In the new container, everything that is available in the image, that is 2 Python files and 2 Java files, along with that Git software and Maven software, everything is available. So have I taken the complete backup of the software, complete backup of the operating system? Yes. So what is the typical definition of OS level virtualization? The typical definition of OS level virtualization is if I have an operating system and inside the operating system, I have some folders, files, softwares, packages, everything is there. And if I want to take the backup of complete operating system, that process is known as OS level virtualization. Now, are we able to take the complete backup or not? Yes. This process is called as OS level virtualization, and we are successful in taking the complete backup. So if you want to come out of it, Control D. That's how you can come out of the container. Okay. So the process, whatever we have done so far. Okay. What the process, whatever we have done so far, have I used any Docker file? No. So the process. So here, Docker run, if you execute this one, you will be inside the container. You will be inside the newly created container. Newly created container. Once you do this, if you execute, okay, execute ls command to see the files, okay, and execute git hyphen version and mvn hyphen version to see the softwares. Okay, to see the software. If you are able to see, okay, if you are able to see everything inside, if you are able to see everything, then it is known as OS level virtualization. What is OS level virtualization? Complete backup of operating system. Okay, complete backup of operating system. That's the OS level virtualization. But what we have to remember is the process, whatever we have done so far. Okay, the process, whatever we have done so far is not being done in the real-time scenarios, is not followed, I can say, is not followed in the real-time scenarios. Why we don't follow this process in the real-time scenarios? Because we are not using the Docker file. Docker file is something that will simplify the task, that will automate the task. Why we are not using this one? Because it is completely a manual process. Because it is completely a manual process. We don't want to do the manual process. We want to do the automation process. In order to do the automation, okay, in order to do the automation process, we have to create, okay, we have to create a Docker file. Okay, we have to create a Docker file. So in the Docker file, what we will do, inside the file, that is inside the Docker file, we are going to write, okay, we are going to write everything that we need to install. Okay, so we are going to write everything that we are going to write or configure, you can say. It's technically write or configure, you can say. Anything is same. Okay, we are going to configure everything that we need to install. In it can be softwares, it can be files, it can be packages, it can be anything. Okay, so the purpose of Docker file. Okay, the purpose of Docker file is to do the image automation. Okay, is to do the automation, and this is something that is done in real-time scenarios. Okay, this is done in real-time scenarios. Okay, so the automation in real time is basically done by using Dockerfile. Okay, the automation in real time is done by using Dockerfile. We will talk about Dockerfile in the next video. Next video, we are going to focus on creating the image and then sending that image to the Docker Hub. Currently, I have just created the image, but we need to send the image to the Docker Hub also. That we will see in the next session. In the next session, I'll write a simple Docker file with a simple commands only, which I'll be talking in the next session. Okay, so I hope you now got the idea about what is meant by OS level virtualization and how to copy the content from a container to an image. So you can see everything that is available here. In this video, we have understood what is meant by OS level virtualization, and we have seen how to copy the content from container to image, and by using a custom image, how to create a new container and how to take the complete backup of the operating system. So in the next session, we are going to talk about how to create a custom image and how to push that image to the Docker Hub account. Thank you.